Hello everyone, welcome to the daily dose of mathematics. Today I'm going to solve a very important question which I was also not able to solve in the first go, even though I had a very upper hand in integration, just because this question involves a lot of particular steps. Now, if you don't know these particular steps, you won't be able to solve this question in general. So let us try to understand how to solve such a kind of a question. So after seeing this question, the first thing which will come to your mind is let us try to substitute. So let us try to substitute tan x is equal to, and say I am substituting it equal to t square. Then this will come out to be equal to sec square dx is equal to 2t dt, and this will appear as dx is equal to 2t dt divided by 1 plus sec square x, which is 2t dt over 1 plus 1 plus tan square x, and this will come out to be equal to 1 plus t power 4. So this is 1 plus tan square x. Sec square x can be written as 1 plus tan square x. So 2t dt by 1 plus t power 4. So on writing the value of tan x, root over tan x and dx here, I'll get t into 2t by 1 plus t power 4 dt, which turns out to be equal to 2t square divided by 1 plus t power 4 dt. Now, unfortunately, stop here and try to understand. This still cannot be solved further. Why? Because if I substitute t as something, or t square as something, or t power 4 as something, or 1 plus t power 4 as something, we won't be able to solve this further. So what we need to do here is a very particular step, and you should write this as t square plus 1 divided by 1 plus t power 4 dt plus t square minus 1 divided by 1 plus t power 4 dt. So what I have done here is I have split 2t square into t square plus 1 and plus t square minus 1. So plus 1 and minus 1 will get cancelled out, and this will be 2t square. So 2t square I am writing as t square plus 1 plus t square minus 1. Now very particular step again here. So I'm just making it more complicated, but that's not the case actually. So here what I'll do is I'll write this as integration of, and I'll take t square common. Now this is also not an obvious step, so just uh, be careful here. Divided by, and I'm going to take out t square common from denominator as well. So this will be t square plus 1 by t square dt. I'm solving only this part. This part I'll do it later. Now obviously t square and t square will get cancelled out, and then still, as you can clearly observe, that this is t square plus 1 by t square and this is 1 plus 1 by t square. How to solve it further? Now again, a very non-obvious step here involved would be, let t minus 1 by t is equal to u. Why I have done that? Because the differentiation of t minus 1 by t comes out to be 1 plus 1 by t square. So on differentiating it, 1 plus 1 by t square dt is equal to du. Because the differentiation in the numerator is available, that's why I have taken this particular step. So we have to be a bit more careful here. So this implies this can be written as du divided by, and this can be written as t. So on so I'll remove it and I'll write this as, on squaring this I'll get t square plus 1 by t square minus 2 is equal to u square. So I have squared both the sides and I have gotten the term t square plus 1 by t square. So I can write the integration now as du divided by u square plus 2, which is the standard integral altogether, which can be written as 1 by root 2 tan inverse u by root 2. and then you can substitute back the value of u, and then you can substitute back the value of t. But this is still not solved. I have to solve this part further. What I can do here is, in a similar manner, I'm quickly going to do that. T square common 1 minus 1 by t square dt divided by t square common t square plus 1 by t square, and then this cancels out. I'll substitute t plus 1 by t is equal to, say, another variable v. So 1 minus 1 by t square dt is equals to dv, and this comes out to be, on squaring this, t square plus 1 by t square plus 2 is equal to v square. So this comes out to be equal to integration of dv divided by v square minus 2, which would be a logarithm, and logarithm rule of x square minus a square, which is 1 by 2a log of x minus a divided by x plus a. So I have to now substitute back the value of v and then the value of t, which is root tan x. So basis that, I would be able to get the entire answer by adding both of them. So it is 1 by root 2 tan inverse u by root 2 plus 1 by 2 root 2 log mod of, and you can check it, v minus 2 v minus root 2 divided by v plus root 2. So here it should be root 2. X minus a divided by x plus a. A is root 2. So I'm going to write this plus some constant of integration c. Now what was u? U was t. U was t minus 1 by t, and t was root tan x. So the answer will come out to be root 2 tan inverse root tan x minus 1 by root tan x divided by root 2 plus 1 by 2 root 2 log, and v was actually root tan x plus 1 by root tan x minus root 2 divided by root tan x plus 1 by root tan x plus root 2. I can leave the answer like this also. I can leave the answer like this, or I can solve it further also if required. So the final answer will come out to be 1 by root 2 tan inverse tan x minus 1 by root 2 tan x plus 1 by 2 root 2 log of tan x plus 1 minus root 2 tan x divided by tan x plus 1 plus root over 2 tan x plus c. That is the final answer for this question. So it's a lengthy question, and there are some non-obvious steps. Again, repeating it, putting tan x equal to t square is still obvious, but writing 2t square as t square plus 1 and t square minus 1 is pretty non-obvious. So we have to be very, very careful here. Second is, whenever taking out t square common from here, and whenever 1 plus 1 by t square is in the numerator, I'll substitute t minus 1 by t as u, and whenever 1 minus 1 by t square is there, I'll substitute t plus 1 by t is equal to v. So these are pretty non-obvious steps, this step, this step, and this step. So we have to be extra cautious here. That's it. So we have to be careful here, and this is how we are going to solve this problem. Thank you.